Alright class, this video is going to be not the entire packet, but almost. So what I've done is I've chosen pretty much the hardest problems on the packet that I think you'll have questions on. And those problems are 18 through 21, 28, 29, 36, and 39. Alright, so right now what we're looking at is this front page right over here. It says use the given information to answer the following questions, and we're going to answer questions of 18, 19, and 20. Okay, so we have three functions. We have it represented in different ways. So the first one is as a table, the second is as an equation, and the third being as a graph. Okay, so in 18, 19, and 20, it's asking questions about those differing graphs right there. Alright, so let's look at this. So let's look at 18. It says, what is the y-intercept for function 1? Well, if I look at function 1, it's not really given to me as an equation where I can just immediately identify what is our y-intercept. But by looking at this, we can find out what is our y-intercept. Alright, so I'm going to put y-intercept. Now I hope you guys remember the chant that we do. It's y-intercept x is 0. Alright, so y-intercept x is 0. If I want to find the x-intercept, y is 0. So over here I'm going to put x is equal to 0. Well, how about I look at where I have all my x's? I see x is 0 right over here. Well, what is our y? What is our y? Well, it looks like it's going to be -3. Okay, so in this problem, my answer is A. So I'm going to say that again. I want to find the y-intercept. Okay, y-intercept, x is 0. X-intercept, y is 0. So y-intercept, where is x 0? Over here. If I want to find the y or the x-intercept, alright, x-intercept, y is 0. Well, where is y 0? It's 0 right over here. So my x-intercept is actually 1. But that's not what they asked, and the answer for 18 is A. Alright, fine. And number 19, that's the next one. Which function has a greater rate of change? Now, I already put over here that when you think of rate of change, you want to think of it as slope. Alright, so which one has a greater rate of change? It can either be function 1, 2, 3, or they are all the same. Well, let's look at this. Looking at, you know what, let's look at the first one. Okay, let's look at the first one. So for this, it looks like, if I want to find slope, I'm going to write it up here. It's m equal to, you want to find out what is your change in y over your change in x, right? How much you're rising, how much you're running. Alright, well, let's look at our y's. I see a pattern here. Looks like this is increasing. It's increasing by +3. So over here, 3 would be in our numerator. Okay, now let's find the change in x. It's coming from 0 to 1 to 2 to 3. Looks like those are all increasing by 1. Okay, so for this table, the slope is 3 over 1, which we know it can be simplified to just 3. Alright, so right next to it, I'm just going to write m equal to 3. Okay, that took some work, right? Not too much. Basically, we knew that slope is rise over run, y over x. Function 2. Function 2 is a little bit easier, right? It's in slope-intercept form, y equal to mx plus b. Where the m is the number right in front of x. We already know what it is. It tells me right there. Okay, not much math involved here. And all I gotta find is that m is, well, it's 3x. So our slope is 3 for function 2. Okay, so far, function 1, function 2, they have the same slope. That slope being 3. Okay, and now function 3 over here. Now I have a slope over here. It's positive, so I know it's gonna be a positive number. You know what? Whenever you want to find slope given a line, you really want to choose two points on the line. So I'm gonna choose a point right over here. And a nice point that I want to use, what about this one right over here? Okay, now like I said, slope is rise over run, so let's figure out how much we're rising. Looks like we're rising 3 units up, so it's a +3. And 1 unit to the right, so it's a +1. So this slope is 3 over 1, and that simplifies to 3 as well. So our slope for function 3 is 3. M equal to 3. So A, B, C, or D, none of them kind of outrank each other, so they're all the same, so it is D. D is the correct answer for number 19. Okay, now number 20, it says which function is a proportional relationship? Now, proportional relationship, that sounds kind of weird because you're kind of wondering, this really isn't a word that we come across. But basically what that means is, do they have the same equation? Okay, so what we have to do is we have to find the equation of every single one of these and see if they all have the same equation, then this is, they're all proportional relationships. Okay, so which function is a proportional relationship? Let's look at... Alright, so we already have the equation for function 2. Okay, easy peasy. Now, it might be a little bit difficult to find. Actually, no, it's not even difficult at all. Here, let's look at function 1. We found the y-intercept from number 18, right? We found that y-intercept b is equal to -3. And we also found that the slope of all of them was positive 3. So writing that for function 1, the equation for it is y equal to 3x minus 3. Okay, well, just comparing that with function 2, which is y equal to 3x plus 5, that's not even the same. Okay, so they're not the same equation. They're not what we call proportional relationships. Well, let's do the last one. Last one, same thing, slope is 3. But over here, if I look at my y-intercept where it crosses the y-axis, that's what it means. It looks like it's at positive 1. So that equation, I'm going to write it right over here. Y equal to, the slope is 3x, or the slope is 3. I put an x, and then our y-intercept is plus 1. Okay, so it turns out that none of them are proportional relationships, so D is the correct answer. Okay, next one. Next one is 21. Now 21, it gives you a bunch of numbers represented in different ways, where we have a power, or number raised to a power, we have a fraction, we have an irrational number of pi, we have also another irrational number of a square root of 3. Alright, so let's figure out what these things are actually equal. Let's try to convert them into decimals and then see from there how we can order these from least to greatest. So the first one is square root of 3. Okay, second one is 2 pi. I can draw a pi like that. Third one is 9 over 2. And the last one is 2/3. Okay, so let's really distinguish what these things are equal to. Now, square root of 3. Square root of 3, there's going to be a lot of estimating here, okay? Now, you really want to go the opposite way. I want to work with, I'm not going to work with square roots, I want to work with squares. So we're going to work with, how about I do 1 squared, 2 squared? Okay, what is 1 squared? 1 squared is 1. Okay, that's 1 times 1 is 1. 2 squared is 4. Okay, so in a similar fashion, we can say that the square root of 1, well, that's 1. The square root of 4 is 2, right? If you have a number squared, that asks you the question, what number times itself will give me this number? So the answer is 2 because 2 times 2 is 4, 1 times 1 is 1. But what I want to find is the square root of 3. Okay, well, if I had the square root of, so let me draw a number line for this. Square root of 1, okay, that's at 1. We'll go 1, 2, oops. Square root of, let's say square root of 2. Square root of, you don't want to do that. Let me just put square root of 4 right over here. Okay, and square root of 3 is probably somewhere over here, right? We have a 2 over here. So it's somewhere in between square root of 1 and square root of 4. So it's probably going to be a decimal. Let's just estimate here, just so we can kind of get a good idea of what square root of 3 is. It's probably, let's say, 1.4. Okay, 1.4. So I'm going to erase this other stuff. Alright, so I'm estimating that square root of 3 is in between 1 and 2, right? In between 1 and 2, the square root of 1 and the square root of 4. Okay, so let's just estimate, we're going to say it's 1.4. So next one is 2 times pi. Well, first off, what is pi? Now, pretty much you know that pi, it goes on forever and ever and ever, but we kind of stop it. Pi is just, it's 3.14. Okay, well that's a good fact to know. Now I'm going to multiply that. It's saying 2 of those pi's. So I'm going to multiply 2 by that. And it looks like this is going to be 6.28. Yep, 6.28. All I did was multiply 2 times 3.14, and that's what 2 pi is equal to. So kind of rounded there. Alright, so we're working with decimals. Let's get now this fraction in decimals. So we have 9 halves. The way you convert a fraction to a decimal is that you divide the numerator by the denominator. So I'm going to divide 9 by 2. Okay, well 2 can go into 9. Looks like 4 times. Okay, 2 times 4 is 8. Subtract these two, we have a remainder of 1. Okay, I'm going to put a decimal over here right above the 9 and above our division symbol. We're going to introduce a 0, bring that down. Alright, well it looks like 2. 2 goes into 10, 5 times evenly, right? Because you have 10 minus 10 is 0. So this number, 9 halves, is 4.5. Okay, so now we have another one, right? Not too hard here. If you get the overall process, right, if I looked at these original problems, this might be kind of confusing. Okay, this might lead me to guess. Okay, but we can work this out. And finally, we have 2 to the third power. Well, what does 2 to the third power means? What does it mean? It just means 2 is being multiplied by itself 3 times. Okay, so 2 times 2 times 2. Well, 2 times 2, well that's 4. Times another 2, that's just 8. Okay, finally we have all our numbers here. We have 1.4, 6 and 28 hundredths, 4 and 5 tenths, and 8. Well, it looks like we're going to have, which one comes in first place? Looks like this one's in first place. Second place is this 9 and 9 halves. Next one is right over here. And fourth place is this 8 over here. Okay, so should go square root of 3, 9 halves, 2 pi, and 3/8. Let's see which one says that. So square root of 3, 9 halves, 2 pi, 3, or 2 to the third power. Okay, so our answer for this is D. Right? Took a little bit of time, but not too much. Okay, pretty much that's within the realm of you being able to solve this. Okay, pretty confident you guys can do a problem like that. Alright, so next problem we said we're going to do number 28. So we're going to skip a couple of problems. Let's go to 28 over here. 28 deals with types of numbers. Alright, and the problem asks us is classify these numbers by selecting all that apply. Okay, so all that apply, we have integer, irrational, rational, and real. Okay. So, before I go over these type of problems, let's talk about the differences between these words. Okay, so integer is just, you deal with integers primarily in mathematics, right? Integer, those are numbers that are just like 1, 2, 3, 4, 5. They're also negative numbers, so like -1, -2, -3. Okay. Well, looking at these, do I see anything that looks like that? Or even simplifies to give me an integer? Not quite. Okay, so I would probably cross out 1. Okay, and even if you look at your choices, none of them say 1. Okay, none of them say integer, so that's kind of a clear indicator that none of those are integers. Okay, now it comes to irrational, rational, and real. I'm going to talk about rational first. Now, rational, those include integers, right? They can be these, but rational numbers also include decimals, decimals that we call terminating. Okay, all that means is that it stops. So we could have probably like 0.83, so 83 hundredths. That terminates, so that would be rational. Square roots, that simplify, so like square roots of 4, right? Square root of 4 is 2, so that's rational. We consider things, so those are all rational numbers. Rational numbers can also be expressed as fractions. But I don't want you to confuse that with what we have for that last one, square root of 7 over 2, right? Not quite. That gets us to irrational numbers. Irrational numbers are these nasty, nasty numbers that there's not really a good way to write them, like what we dealt with earlier. We have square root of 2, right? Square root of 2, you ask yourself the question, what times itself will give me 2? Turns out that it's going to be a decimal, right? 1 times 1, well that's just 1, that's not going to give me this. Like square roots of 17, There is no number that you can multiply by itself to give you the square root of 17. So these are what we call irrational numbers. Irrational numbers also include pi. Okay, so anything that has a square root that can't be simplified. And also irrational numbers can be decimals that never terminate. And that's what sometimes pi is. Or you like to think of pi. Next one is real. Okay, so real is pretty much any numbers that you deal with. Pretty much any numbers that you've seen so far, those have all been real. The opposite of real is what we call imaginary. You won't see imaginary probably until you get to maybe algebra or algebra 2. But something that it isn't an actual number. So just to kind of prelude into what you're going to be learning in the future, but like square root of -1. This is what we call, it's not real. Okay, there is no number I can multiply by itself to give me a negative number in the square root. Right? It's not possible. Like if I were to multiply a positive number, well, positive times positive is a positive, so that's not possible. And what about negative? So negative times a negative, well, that's also positive, so that will never happen. Okay, so it turns out that these numbers, that's not the case, so they're all real. Okay, now comes the question, are they rational or irrational? Well, these are pretty not nice numbers. Okay, so these are what we call irrational. If they were rational, they'd be a fraction. Like if we just only had 7/2, right? That's a nice fraction. That would be rational. But since we have square root of 7/2, that's not rational. So our choices are, it's 2 and 4. So the answer is B. Okay. All right. Next one. Next one is 29. 29. 29 says, which of the following representations are linear functions? Okay, well, we know linear functions put together kind of sounds weird, but we know what it is. Linear just means what gives me a line. Functions, we've already talked about that. Every input gives me an output. Alright, well, looking at this, does this form a line? We don't know yet. First, let's determine whether it's a function. Does every input have one output? Okay, well, when the input is 2, the output is 7. When the input is 6, output is 4, input is 0, output is 3. It looks like every one of these, it forms a function. Now, does it form a line is the question. Okay, let's determine that. So how about I take these points and I graph them. So I'm going to use this whiteboard right over here. Okay, so you might want to follow along while you're watching this video, because I'm not going to be able to show you the coordinates. But the first coordinate is 2, 7, meaning 2 to the right, 7 up. So it looks like right over here, right? 2 to the right, 1, 2, 3, 4, 5, 6, 7 up. That's the first one. Next one is 6, 4, so 6 to the right and 4 up, right there. Next one is 0, 3, so just 3 up. 3, 6, so 3 to the right, 6 up. And last one is 1, 5, so 1 to the right, 5 up. All right. Well, looking at what the problem asks us is, we determined it is this function, but does it form a line? Looks like it doesn't, right? All these points is kind of just all over the place, so it doesn't form a function. So we can eliminate 1. All right. So anything that says 1 right now, eliminate. So we're getting rid of A, we're getting rid of D. So right now it's in between B and C. All right. Well, the thing is, if we look at this, they both have 3. Okay, so we can already tell that 3 will be a linear function. And the way you can tell is that, is there a pattern here, right? Just like how we had slope. Slope has a constant rate of change, never changes. But let's look at this. Our outputs, well, those are our y's. Inputs are our x's. Looks like we are increasing by a constant amount of just adding 1. It's getting bigger by 1. Our x's, our inputs, and it looks like it's increasing as well, right? From -3 to 0, 0 to 3, 3 to 6, 6 to 9. We're constantly adding 3. And this has a slope. M is equal to, well, it's y over x, so it'd be 1/3. Alright, so they didn't ask us for the slope, but we could tell that this thing constantly increased by going up 1 and then to the right 3. But the question is so we determined that 1 is not a function, not a linear function. 3 is a linear function. It forms a line, and every input has one output. But this one right over here, it turns out we have y equal to 2 to the x power. Now, you haven't seen anything like this, but the way you can tell is that typically when we have lines, we have them in slope-intercept form. Y equal to mx plus b. Well, look at the form there. Do we have any exponents? Do we have a variable as an exponent? No. Okay, so this in no way does this form a line. So the answer turns out to be that it's only 3. Okay, when you get into algebra, this is actually something that we call an exponential. Alright, so there's different types of graphs. Right now we're only working with lines. That's called an exponential, so you're not going to learn that just yet. Okay. Alright, next one, we're going to have 2 more. We're going on to skipping a couple problems. We're going to go to number 36. So 36, skip that page, skip to this page, and right over here. Okay. Now, I'm going to be doing some board work over here, but let's read the problem first. So it gives us 2 triangles, diagram over here. It says triangle ABC is similar to triangle KLM, where the ratio of the proportionality, right, it's comparing these two. It's saying that it's 2/3, right? This is 2/3 of that. Okay, it's 2/3 as big as that. Okay, so it's a little bit smaller. And AB, that looks like it's important, is equal to 12 centimeters. All right, I'm gonna label my units there. And what it's asking us is, it's asking us what is KL. So what is this guy? I'm gonna put an X for that. All right, a couple of things to talk about, things I haven't mentioned, is this concept of similar and probably the ratio proportionality of 2/3. Okay, similar. What does similar mean? Similar just means that they pretty much have the same shape, but different size. Okay, so just like how we had those triangles where one's bigger and one is smaller, right? They look the same. Well, they don't look the same. The shape is the same, but one is bigger than the other, right? You can also think of that as the same as, well, what if we have a stick figure? We have this guy and this guy, right? We're similar, right? We're similar, but we have the same shape, but not the same size. Okay, that's how we can kind of tell that people are people, right? If you see like a dog, you're like, wow, that guy is not similar to me. Okay, that's one picture of a dog. All right, does that look like me? No. Alright. So similar just means, again, same shape, different size. So same shape, different size. Now the proportionality of it, it means that, like I said, that this is 3 or 2/3 bigger than this. Okay, well, it looks like we're comparing the same side, right? We just said that AB is this, and we want to find KL. And we have this way to compare it. Now we could set up an equation, but you know what, I'd rather do something else. It turns out that I'm going to multiply this 12 by 2/3. Now multiplying a number times a fraction here. Now I'm going to give you a trick. I found this trick to be very, very useful. And it's this. I'm going to give you a couple problems. So we're going to kind of push that off to the side for now. If I were to have 4 times, let's say 2 halves. I'm going to give some other ones. Let's have 10 times 5/3. Okay, and what about 50 times, we're going to have 12 sevenths. Okay. Now, whenever you have a fraction and you multiply it, you want to think of this. The numerator, it multiplies that number. The denominator divides the number. Okay, well, we can work with that idea, right? So this is saying half of 4. You know that half of 4 is 2. Well, if we look at this, since the denominator divides it and the numerator multiplies it, what is 4 divided by 2? Well, it's 2. Okay, multiply by 1, it's still 2. Okay, I'm going to say it again. The denominator divides it. So 4 divided by 2 is 2. Multiplied by 1, still 2. Alright, let's use this. 10, remember denominator divides it, so 10 divided by 5, that's 2. And 2 times 3, that's 6. Okay, pretty easy. Now let's look at this one. We're going to have... Ooh, whoops, let me change this, 12. That doesn't work. Let me change it to 10. Alright, we're going to have 50 divided by 10. Well, that's 5. 5 times 7 is 35. Okay, now you can also work the opposite way. Like if I were to multiply first, right? 4 times 1 is 4, divided by 2 is 2. We could take 10 times 3, which is 30. 30 divided by 5 is 6. 50 times 7 is 350, divided by 10 is 35. Okay, so it works the other way too. Alright, so that's just kind of a mini lesson right there, just to help you prepare for this. Okay, so now we have 12 and 2/3. Well, 12 and 2/3, I'm going to take 12 divided by 3, that's 4. 4 times 2 is 8. Okay, so it's 8 centimeters. So that is C. Alright, let's go on to, so that now we have one more, last one, which is 39. Now, 39, I really haven't talked about, but we've kind of talked about things that are similar to this. But I'm confident that you guys can do this on the test. So you will see a problem that's very similar to this on the test. So number 39, it says, in the diagram, line AB, okay, so that's line AB right over here, is the hypotenuse of the right triangle ABD. Okay, so triangle ABD, it's saying that this guy's what we call the hypotenuse. BC, over here, is also the hypotenuse, but of this smaller triangle. And we have to find, we have 3 statements, which statements are true. Alright, now just to talk about, just to kind of clear up any misconceptions, is this. Let's just talk about a right triangle. That's just a triangle that has a 90-degree angle. You guys should have seen this before, probably elementary. But whenever we have a right triangle, the longest side of the right triangle, the side opposite of the right angle, we call it the special name. It's called the hypotenuse. Okay, so all it's saying, all this statement is saying that AB is the hypotenuse of this triangle. Alright, I'm going to shade that in. And BC is the hypotenuse of this triangle. Well, kind of looking at the last one, right, we talked about the idea of being similar, same shape but different size. Well, look at this. They look like the same shape, right? But different size. This one's a lot bigger than this one. Okay, so these two things look very similar. Ooh, and I see that in one of the statements. I see that on the second statement. Triangle ABD is similar to BCE. Okay, so I'm going to circle that one. I know that one is true. Alright, we just talked about that. So which ones can we eliminate? Well, that one has a 2, this one has a 2, that one has a 2. D is the only one that doesn't have 2. Let's see which ones are also the same. I'm going to come back to 1. Let's go to 3. It says the slope of CB, okay, that's this right here, is less than the slope of BA, which is right over here. Well, we could compute rise over run, and we could do all that, but just look at the lines. They form a straight line. We're not saying that one, decreases like this and the other one decreases super fast. Nope. It has the same rate of change, the same slope throughout. So actually, it's not less than. They're actually equal. So 3 is not the correct answer. Okay, so let's cross that out. That guy is not true. So in our answers, we can cross out which ones that have 3. So we have B. Let's cross that one out. Now before I get to 1, let's decide. They both have 2's, right? A and C both have 2. Now A is the one that has, A is the one that has 1. C does not. So let's see if 1 is true. Now this is set up as a proportion. It's saying that CE, we're going to compare that to BD. Okay, are those two things, do they compare to each other? Alright, well, and also we're going to compare CB to DA. Okay, so I'm going to use 2 different colors over here. Let's see if we get something that creates a true statement. Alright, so CE. CE is this distance. Okay. Now, we're going to say that that's equal to BD. Okay, well that compares to this distance. Alright, I agree. Just like how we had this side matching with that side, right? The left-hand side over here. And we can also say, what it's saying the denominators now is that CB, well CB is over here on this triangle. And DA is right over here. Okay. Now if I'm comparing, this looks like it's the hypotenuse, right? In this triangle, I would also be highlighting the hypotenuse, but looks like in this case I'm not. Alright, so this statement turns out to be, it's not true, it's false. Okay. So it's actually only 2. Alright, so 2 is the correct answer for that. If you have any questions on any of the problems or these problems, just clear certain things up, make sure that you email me, go to tutoring, any of that. Alright, thank you.